Hi everyone, thanks for checking this out. What I want to do in today's video is to examine a couple different types of UV reactive paint and the qualities they exhibit, like the consistency of the paint, how well it reacts under black light, how long it glows, and see if we can draw any objective comparisons. If you haven't already, you should check out my first video in this series that goes over the physics of how black lights and glow-in-the-dark paints work. So these are the four paints we're going to be comparing. Starting on the left, I got these from Amazon. These are about as cheap as you can get. I think I got the entire box for about 10 bucks. And this is very generic too. You'll find this particular case available under a bunch of random brand names. Next up is Space Beams, Technoglow, and Wildfire. I got all of these in green so we could have a generally same comparison. Here's our Amazon cheap paint. It looks like a decent green in the lighting I have going on here. It's labeled phosphorescent, so I expect it'll glow when the lights are out. Let's check out the consistency. Very runny. A very liquid consistency. Very, very runny. Seems like it would take a lot to get a bunch of coats on this. Next up is the Space Beams paint. This one has a much paler color to it, already giving me glow-in-the-dark only vibes. Definitely thicker than the Amazon paint though, not by much. Here's the Technoglow paint. Same visible color as Space Beams. I realized after I bought this that they offer a green glow that's colored green rather than this pale color. So I might have to get that just to test it as well. Actually, this one has a nice consistency. It's a little thicker than Space Beams and Amazon. I think this is the minimum viscosity I'd go with if I had to pick one of these first three to use. And finally, the Wildfire paint set. I've had this paint set for a while. I really love it. I'm trying really hard to fight my biases for this comparison. Yeah, this is a really nice paint. You can see it's a lot greener than the other ones visibly, and that's because it's an actual acrylic. Unfortunately, I've already gone through this green quite a bit and it's dried up. So here's one I haven't used as much just to show how thick it is. That's a very thick, proper acrylic paint. And look how nicely that color goes on. We'll have to see how it compares to the other paints. And this is the paint panel I've prepared. We have our Technoglow right here, our cheap Amazon paint here, Space Beams down here, and Wildfire paint up here. Before painting these colors on, the first thing I did was put 2 coats of an all-white primer on. Primer is important for a couple reasons. One, anytime you're painting, you want a good primer. It doesn't have to be white, but in this case, white is best. It helps with adhesion of the paint we care about. If we were to paint on something unprimed, it might wash off or not adhere and wear off quickly. Also remember what we talked about in the last video. White is the most reflective color. So, when you put down glow-in-the-dark paint, don't forget that it's glowing in 360 degrees, including backwards towards whatever you painted on. And so, by having a nice white coating on the back, you're encouraging more of that glow that's aimed away from you to reflect back out, which enhances the intensity of the glow. I sprayed the rest with black so we could have a good contrast between panels, and so we can see how the visible purple from the black lights look against a moderately reflective black. I tried to get matte black to minimize the reflectivity, so it's a good basis for what you typically find surrounding glow paints. Alright, let's talk about the actual paints on here. You can already see a difference immediately between the paints. You can barely see any paint on there. I promise you it's there, as with this one here. So these 2 paints, the Technoglow and Space Beams, have a very transparent look to them. It's hard to see in the camera, but you can just barely see that kind of pale yellow. This cheap Amazon paint actually turned out pretty good as far as daylight color goes. It's a pale green, very thin, but still greener than these other 2. Went on slightly thicker than water. Obviously, the biggest difference is the Wildfire up here. It's the boldest green that we have. It went on very smoothly, like an acrylic paint should. The coverage on it is really nice. It's not as nice as it should be because my set is a few years old and I had to reconstitute it a bit, but the Wildfire paints go on and just blend so nicely. And now that we see what these look like under normal light, let's see what they look like under black light. We'll start with the common 400 nanometer blacklight. But before we get to that, I'd like to insert one final bit of classroom knowledge here. This will be quick and pertinent, I promise. When you turn on a light, it emits that light in various directions, all over the place. Typical bulbs emit in nearly 360 degrees. LEDs anywhere from 60 to 180 degrees. LEDs are of particular interest to us, so let's focus on those. LEDs emit most of their power within a cone aiming straight ahead. As you get further from the center of the light, the energy of the light decreases. Light energy also follows the inverse square law. To put this simply, anytime you double the distance from the light to an object, the light's energy suffers a 4-fold loss. Combined with LEDs diminishing energy the further away from the center of the beam, this means any light emitted off the center line will have slightly further to travel and thus have less energy reaching the object. The loss of energy from both distance and angle can be calculated to form what's called an irradiance pattern. By looking at an irradiance pattern, you can tell, given a certain wavelength and distance from the center, how much energy is hitting the object you're trying to light up. This pattern shows the 365 nanometer blacklight at a distance of 6 feet, approximately the same distance I have my light set up. At the center, my board is getting hit with 23 milliwatts per square centimeter of energy. As we get further out from center, the energy begins to decrease. If I were to move another 3 feet away, back to 9 feet, the center only receives 14 milliwatts per square centimeter. The power is almost halved just by moving 3 feet further back. I bring all this up so you can be aware of how distance and angle can affect your blacklight setups. It doesn't take a lot to make good fluorescent paint glow, but as you add distance, like, for instance, when trying to light up an entire yard scene with a single blacklight, the effectiveness of that blacklight drops exponentially. Some people attempt to compensate by buying bigger and bigger wattage blacklights. This can backfire, because though you are getting more UV, you're also getting more waste light that can end up drowning out your glow. Remember that some lesser quality blacklights barely put out any UV at all, and rely on customers mistakenly thinking the purple waste light is what's making things glow. Okay, back to the paint experiment. I'm ready to turn on the blacklight. I've also put this here. This is going to be our control block. This is painted with the non-fluorescent industrial white paint. So the only light coming off of it will be reflected visible light. It will help give a better sense of how much what you're seeing is due to UV glow and how much is just reflected light. This is what they look like with a 30 watt 400 nanometer blacklight at a distance of about 6 feet. You can see the Techno Glow in the top left and the space beams in the bottom right look a little dimmer than the other two. So their fluorescence with this light is okay. Not bad. You can also see the brush strokes because they're so thin, they're really hard to blend. The cheap Amazon one on the bottom left actually looks pretty decent. Honestly, a bit of surprise, but there it is. It's glowing a nice bright green. And the wildfire on the top right, in my opinion, is still the most solid of them all. It helps a lot that it mixes really well and doesn't show the brush strokes as much. And the control board at the bottom is showing that purple visible light, but no fluorescence. Now let's see how they glow when the black light is removed. You'll notice immediately that the wildfire paint goes out. That's because wildfire is purely fluorescent. As soon as the UV light is removed, the light goes out. You can see the ones that were dimmer in the daylight are now glowing intensely in the dark. Now, actually, let me adjust my camera a bit to show what I'm seeing a bit better. There we go. The Amazon one on the bottom left is glowing, but the glow is minuscule. It's barely perceptible to me right now, and hopefully you can see that too. We'll do another experiment later where I leave my camera on time lapse and see how long it takes for each of these to completely exhaust their glow. Okay, so we've seen what they look like under the 400 nanometer blacklight and under no light. Let's see what it looks like with the 365 nanometer true blacklight. So that looks really different already. You can see the wildfire and the Amazon paints almost look dimmer than the other two phosphorescents. The space beams and Techno Glow are glowing a little more intensely. You can also see there's almost no reflection off both the control block and the black paint from the blacklight. Just that bit at the top there because I can't hold the light any higher. The green light you see on the control block is almost entirely a reflection of the glowing paints. Let's see if this blacklight charged up the glow any more than the 400 nanometer one did. Those look just about the same. I'll put up a side-by-side and see if we can notice anything, but it doesn't seem to take much exposure to UV, either from a 400 or 365 nanometer blacklight, to fully charge all of these paints. Now there's one last test I'm going to run. I'm going to take the 365 nanometer blacklight, charge all these up again, and then leave my camera on time-lapse overnight and see how long it takes for all of these to fully lose their glow. Now, I have no idea how this is going to turn out. I don't think I've ever taken notice of how long glow-in-the-dark stuff stays lit once the lights are turned out. And obviously the wildfire paint won't be competing in this test. I'll start the clock as soon as I turn the lights out. Okay, it looks like our cheap Amazon paint is the first one to tap out at just over 2 hours and 48 minutes. It lost its initial brightness very quickly, as did all of them, it looks like, and then slowly faded out. The space beams and Technoglow are fading too, but hanging in there. And it looks like at 7.5 hours, space beams and Technoglow still have a very faint glow. Now this is the extent of time I could leave them out until sunlight started peeking in again and recharging them. So that's as good as a test as I'm going to get. But that's still pretty impressive. So we can conclusively say that the generic Amazon paint fared well against the other name brands when under blacklight, but it quickly lost its glow when the UV was removed. Both space beams and Technoglow appeared nearly identical in all tests, with the exception of viscosity, which was a bit subjective on my part anyways. And because their price points are nearly identical as well, I'll confidently say that either of those will do the job for you if you're looking for phosphorescent paint. However, Technoglow does have a much wider selection of color to choose from, so that's something to consider as well. Wildfire looked the best in daylight and had a commanding presence under UV, but does not glow in the dark. All of these could potentially suit different needs, so I hope this has been helpful in determining which will be best for you. That just about wraps up this video. But before we close out, I want to give everyone a preview of what my final video in this series will be about. I'm going to run one more experiment with these paints. I'm very interested in how UV affects items outside, how UV from the sun and other factors accelerates degradation of paints and their fluorescent or phosphorescent properties. So what I did was create a second identical paint board. But with this one, I put about 4 coats of Rust-Oleum clear coat on it, then a layer of 303 protectant. Clear coats and 303 are meant to protect from the elements and absorb the sun's UV before it can get to the substrate they're protecting. We'll see if, after a month, there's been any UV degradation on one versus the other, or if both paints shine just as brightly as if they were freshly painted. Catch you then!